right, that's crate 42, 50 kilos.
Copy that. Logging traceability 789.
Look at this. Significant mold and excessive breakage here.
Confirmed. We need to reject this lot immediately. Get that tag printed.
We have significant fungal growth here. This lot is compromised.
Agreed. Tag it for rejection and update the log.
After conveyor transfer, raw tamarind pods are often directed into designated holding bins or intermediate High-capacity spray washers use multiple rows of adjustable nozzles that direct pressurized sheets or fans of clean water over moving tamarind pods.
In the water flotation stage, washed tamarind pods enter a shallow tank or will float with water.
In the secondary cleaning stage, tamarind pods pass through rotating brush washers, where multiple cylindrical brush rollers.
After secondary washing, cleaned tamarind pods are transferred onto dewatering equipment, designed to remove excess surface water.
Tamarind pods are opened to separate the brittle outer shell from the sticky inner pulp, using either manual labor or mechanical dehulling machines.
Done. Shell separation focuses on completely removing the brittle outer husk from the tamarind pulp after the
Shell separation focuses on completely removing the brittle outer husk from the tamarind pulp after the pods have been cracked.
The shells are collected from the dehulling equipment and transferred to composting facilities. They are then shredded.
After separation, dry tamarind shells are collected from the dehulling and screen equipment through dedicated chutes.
The softened pulp is forced through a strainer. In manual methods, the mixture is pressed through a metal sieve.
During fiber extraction, the intertwined network of fibrous strands that anchors the tamarind pulp to the seeds is progressive.
After deseeding and fiber removal, the primary tamarind pulp is directed into stainless steel containers or
In the screening stage, the mechanically worked tamarind mash is passed over perforated screens.
The mechanically worked tamarind mash is passed over perforated screens that exploit size and texture differences.
Separated tamarind seeds emerging from the screening are routed in the fill.
Collected tamarind seeds are first washed to remove adhering pulp, then dried until moisture content is reduced to
Once seeds and coarse fibers have been removed, the resulting pure tamarind pulp is transferred from collection vessels.
Once seeds and coarse fibers have been removed, the resulting pure tamarind pulp is transferred from collection vessels.
Pure tamarind pulp is loaded into industrial grinding machines such as colloid mills or high-shear wet grinders via pumped feed from holding tanks.
Pure tamarind pulp destined for finer texture is loaded into industrial grinding machines such as colloid mills.
To achieve a consistent, target texture, measured amounts of clean water are added to ground tamarind pulp in mixing or processing tanks.
Temperature is monitored closely because friction in colloid mills can rapidly heat the product. Thermocouples are installed.
Multiple grinding stages are used, so tamarind pulp passes through more than one reduction step to achieve a highly uniform, smooth texture. Multiple grinding stages are used, so tamarind pulp passes through more than one reduction step to achieve a highly
Pulp consistency is checked using viscometers and Brix refractometers. If too thick,
Sanitary positive placement or progressive cavity pumps move the thick.
After consistency adjustment, the finished ground tamarind pulp is transferred to heating vessels, typically steam-jacketed kettles or tubular preheaters.
In steam-jacketed vessels, tamarind pulp is heated indirectly as steam flows through an outer jacket.
Pasteurization of tamarind pulp typically involves heating the product to a controlled temperature in the range of about 85 to 95 degrees Celsius. In steam-jacketed kettles processing viscous tamarind pulp, continuous stirring by an integrated agitator
Heat treatment of tamarind pulp at pasteurization temperatures is designed to eliminate or greatly reduce pathogenicity.
Heat treatment of tamarind pulp at pasteurization temperatures is designed to eliminate pathogenic microorganisms such as Salmonella and E. coli.
After pasteurization, hot tamarind pulp is cooled down to an optimal processing or filling temperature, typically closer to ambient or a specified warm range.
After cooling, tamarind pulp that needs to be converted into concentrate is pumped from balance tanks into concentrate. After cooling, tamarind pulp that needs to be converted into concentrate is pumped from balance tanks into concentrate.
After cooling, tamarind pulp that needs to be converted into concentrate is pumped from balance tanks into
In the concentration stage, tamarind pulp is subjected to vacuum evaporation, where the surrounding pressure is reduced.
During concentration,
Tamarind paste thickness is monitored by measuring viscosity and flow behavior.
pH level monitoring in tamarind pulp processing is important because tamarind is naturally quite acidic.
Processors periodically measure pH with calibrated food-grade pH meters during extraction, formulation.
After the sulfadian, tamarind accumulates in concentration and instant filtration removes.
The titratable acidity is high, and the panelists found the sourness too sharp.
We should adjust the sugar content to bring the pH.
Taste and acidity assessment of tamarind pulp or paste, instrumental and sensory method.
Hygienic kukata. Leakage by the cartilation hub.
For long shelves like tamarind paste and concentrate, the product is typically hot-filled in tin. After hot filling, containers of tamarind paste are immediately sealed using caps.
Containers of tamarind paste are immediately sealed to maintain sterility. Each container is then labeled with required information.